Hi everybody, my name is Michael MacInnis. I'm a PhD student at Carleton University in Ottawa, Canada. My supervisors are Professor Olga Baysal, founder and director of the Software Analytics Research Group, also at Carleton University, and Professor Michele Lanza, founder and director of the Software Institute at USI in Lugano, Switzerland. This is the companion video for a paper we wrote called Terminals All the Way Down. But before we get started, a disclaimer. In the paper, and in this video, we aren't talking about Vim specifically, or Emacs or Nano, or any of the other terminal-based editors. We also aren't talking about Bash specifically, or Z shell or Corn shell or Fish, or any of the other Unix shells. We aren't even talking about a specific windowed terminal emulator. What we are talking about is the environment created by all of these programs and supported by the terminal in its latest incarnation as the windowed terminal emulator. Opinions on the merits of windowed terminal emulators have always been divided. On the one hand, we have the view that all windowed terminal emulators give us is an array of teletypes, a limited and unimaginative use of the powers available to us. On the other hand, we have the view that windowed terminal emulators brought great advances in juxtaposability and made a whole new way of working possible. I think we can interpret array of teletypes as obvious hyperbole. This is a teletype. It supports TypeScript-style interaction, where commands and their output are intermingled. The teletype is interesting in that it predates computers. When computers were invented, they were like alien technology. To communicate with them, we grafted on existing devices like the teletype and the punch card machine. But teletypes were replaced by video display terminals like the VT100 shown here. As soon as we moved to video display terminals, we were no longer limited to TypeScript-style interaction. The cursor was free to move about the screen, and the screen could be erased or changed. And video display terminals were replaced by windowed terminal emulators like XFCE shown here. Just like video display terminals, windowed terminal emulators allow us to move about the screen, which enables them to support terminal-based editors like Vim. But with a windowed terminal emulator, we can also interact with what the terminal is displaying using a mouse. And windowed terminal emulators even know about things like hyperlinks, meaning that some of the text displayed is clickable. The details of what I'm typing here aren't particularly important, but we can look at bpython's impressive completion. Notice how when I hover over the URL, it's underlined. If I were to click on it, it would open a browser. And just to show that this isn't a feature of bpython, here we are at the shell, doing a fairly useless echo. And again, you'll notice that when I hover over the URL, it's underlined, and if I were to click on it, it would launch a browser. Windowed terminal emulators, like the Xterm, have actually been quietly evolving into a general support environment for text-based programs. But the real power of windowed terminal emulators comes from the ability to launch more than one. As a simple example of what's possible with more than one windowed terminal emulator, we're going to look at some source code in one window and run a linter in the other. Notice that the window title has been updated to the current working directory. Even before we launch the editor or the linter, some interesting stuff is happening behind the scenes. When we launch these two windowed terminal emulators, they're both configured to launch Bash. Bash is configured so that every time it displays the prompt, it sends an escape sequence to the terminal to update the window title, in this case with the current working directory. So each windowed terminal emulator knows its current working directory, Vim, not surprisingly, knows the name of the file that it's editing. And the linter follows the common convention of file, line, column when reporting problems. We know that the linter is talking about the same file that we have open, and we can easily jump to one of the lines that it's talking about. So here it's complaining that these two lines are cuddled, which is easy to fix. It would be great if after saving the change, the linter reran automatically. And that's not the only area where it feels like the system could help us out a bit more. It would be great if we could click on one of these code addresses and jump to that spot in the file. It would also be great if while editing the file, we could see annotations on lines that are currently mentioned in the output of other programs. To enable the system to help us, we can add a layer of indirection, a server that, like us, is aware of what all the windowed terminal emulators are doing. To avoid having to write a custom windowed terminal emulator in support of this, we can create a client that talks to our server and can be launched by any windowed terminal emulator. For reasons we'll see later, we also split the launching and multiplexing of pseudo-terminals into a separate component. Going back to our two windowed terminal emulator example, everything now passes through the server, allowing it to be aware of everything our windowed terminal emulators are doing. Messages sent to and from the server are encoded as privacy messages, which are ignored by Xterm and all Xterm-like windowed terminal emulators. These messages allow us to transform a fairly direct connection into a multiplex data stream. Here's a high-level overview of how this all works. The server is launched locally. It launches a local pseudo-terminal multiplexer. Windowed terminal emulators are configured to launch our client, passing it the command they want to run. The client sends a request to run the command, bash in this case, to the server. The server forwards this message to the multiplexer, and the multiplexer creates the pseudo-terminal and launches the requested command. All of this is invisible to an end user. The windowed terminal emulator behaves as expected. If we launch another windowed terminal emulator, the same thing happens. The client connects and sends a request to run a command to the server. The server forwards that to the multiplexer, and the multiplexer launches the command. Again, the windowed terminal emulator behaves as we would expect, and if we launched bash or another Unix shell, we can use it to run other commands. Those commands can include connecting to a remote machine or launching a container. On the remote machine or in the container, we can have another instance of our multiplexer configured as the entry point. That gives us the ability to launch additional terminals and have those terminals join our network of terminals. Requests to launch a terminal can come from the session on the remote machine or in the container, or from the local machine. The command is launched where requested and connected to a local windowed terminal emulator. Not every hop requires an instance of our multiplexer. If we're connected to a container on a remote server, the container may have our multiplexer configured as an entry point, but no multiplexer is required on the remote server. We can simply transit through it. We can have a multiplexer installed on the remote server as well, but it isn't required. The multiplexer is also written in such a way that if it finds itself running outside of our environment, it falls back to behaving like a transparent shim. Work on this has started, but it is just barely there right now. There are a number of bugs I'm hoping to get to before people see this video. We can currently multiplex connections and launch additional terminals on remote machines and in containers connected to local windowed terminal emulators, and requests and responses encoded as privacy messages are working surprisingly well. We're cautiously optimistic. We'd love for other people to try it out. Our next step will be seeing how we can use this to enable richer interaction, clicking on a code address, recognizing code addresses in output and notifying editors that have requested notifications, figuring out what those notifications will look like, and what terminal-based editor or editors we can easily modify. So this limited and unimaginative array of terminals, as it turns out, was a great advance in juxtaposability that has continued to evolve into a general support environment for text-based programs, while also adapting fairly seamlessly to remote and containerized environments. That last point is surprising, until we stop to consider that the terminal has always been a portal. What we want to do is connect them. Thanks for watching.